officially live. So, yesterday we talked about simplifying radicals, right? Radicals are square roots, okay? They're the same thing. And we're going to go one step further. But before we actually do that, I want to explain something that might make it easier for you to understand what the best choices would be when you get a number that you don't know what it is. You don't know what the square root is. So if you had the square root of 32, all right, remember yesterday at first somebody said, oh, 4 times 8, right? And we did 4 times 8. We said, oh, great, that's going to be the square root of 4 times the square root of 8. And then we thought, oh, well, that's 2 times the square root of 8. And then all of a sudden we thought, oh my gosh, there is a perfect square in 8 as well. So we have to keep going. We've got to go 2 times the square root of 4 times the square root of 2, right? And then we said, oh, well, that means that's 2 times 2 times the square root of 2, which is really 4 times the square root of 2. All right. So that, it wasn't hard, and it's fine to do that. If you're fine with, as long as you keep seeing, checking what's under the radical sign, and making sure that there is no square root. There's no perfect square that goes into that number, and then you've gotten the simplest one. But like if you had a multiple choice question, it said simplify the square root of 32, and A was 2 times the square root of 8, B was 10 times the square root of a million, and C was 4 times the square root of 2. This would be the only right answer. Even though that is true, this is not simplified. This is fully simplified. You see the difference?
But 8 isn't a perfect square, so how did you...
4 goes into 8.
But
4
a perfect square goes into 8, right? So let's list our perfect squares again. We've got 4, we've got 9, 16, 25, 36, 49, 64, 81, 100, right? And you might have to go further, every now and then, but pretty much most of them you can use. These are what you need. So when you're doing these, the very first square root sign, the very first radical sign, has to have one of these numbers in it if you're going to simplify it. All right? That's what I'm recommending. That you always start with these. So it's not like you're looking at 32. Let me see. It's not like you're looking at just any number, any factor. You're only looking for these going into that number, right? That's all you're looking for. Does that make sense? And one of them, the first one, has to be one of these. Otherwise, if there isn't, then there's no way you can simplify. Right? See what I mean? Are you guys listening? Yeah. So, but we found out yesterday that we could have also, since we took out a 4 twice, look, we took out a 4 and we took out a 4. So 4 times 4 is 16. We could have just gone straight to 16. We could have said that the square root of 32 is equal to the square root of 16, perfect square, times the square root of 2. That also equals 32, right? So that is immediately 4 times the square root of 2. It makes it so much faster. If you start with the highest number, it's so much quicker. And the problem, even though this is, not only is it longer, but the big problem is that people forget to go further. They think they've done it, and then they don't even look at the 8 and realize, oh, shoot, I could have gone further, right? They'll stop there a lot of times if they go that route. So I'm wanting you to start thinking, what is the biggest perfect square that goes into that number? Now, there's 2 ways to do that. I'm going to give you 2 ways to think of it, and you guys can choose either way or both ways, whatever. So the first way.
Divide it in half.
The first way, yes. The first way is divide the number in half. Divide the number in half. Good job, Sal. Divide this number, the number under the square root sign, in half. So half of 32 is 16, right? So 32 divided by 2, is equal to 16. So I'm going to come over to my list here, and I'm going to see if there's a 16 over here. There is! So there's a perfect square of 16 times 2. I know there's not going to be a number bigger than that. There's not going to be a perfect square bigger than half of the number, right? So immediately we solved it just by cutting this in half, splitting this in half, dividing this by 2. Does that make sense? So, and now let's say though we did one, well I should show you way number 2 as well. Wait, should I? Let's see. Yeah. Okay, so we did way 1, now we're going to do way 2, or 2. Way number 1, I'm going to write that. Way number 1, way number 2. Okay, very technical terms here to describe these. Okay, what is way number 2? Oh yes, 32. It is using tree factorization. You guys are great at factoring by trees, right? I mean, like trees, right? 32. All right, so we're going to just think, okay, what? Everybody said 4 times 8, right? All right, so as soon as you see one of these numbers here, you put a box around it, okay? There's a perfect square right there. I'm not done yet. I've got it. So once I've come to a perfect square, I'm never going to go below that. I'm not going to go 2 times 2, right? Because I don't need to. I found my perfect square. Great. So now over here, I'm going to say, okay, we've got 4 times 2. Oh my God! That's another perfect square. Look at that. So I have now 2 perfect squares and a 2. So 16 times 2 is what I would use. Right? You see what I mean? Because I can multiply my perfect squares together to get my...
And you use the prime number.
Right? And you're using the prime number. So it'd be 4 times 4 is 16 times 2.
So give us one that you can't split in half.
Okay. So yeah, let's try one that you can't split in half now. It works really well.
Like 21.
All right, we'll keep our ways then. All right, square root of, I think 24 will work. We'll try that. All right, so we're going to split this in half. Half of 24 is? 12. Could, if 12, okay, so 24 divided by 2 is equal to 12. So I'm going to come over here. Is 12 in this list?
No.
No. Now, should I start looking higher than 12?
No.
No, because there's not going to be any number that could possibly be a factor that's bigger than 12, other than 24 itself, right? You know what I mean? But that's not going to help us because that's what we've got already. We're trying to simplify. So I'm going to go over here. There is no 12. 12 is below 16. So I'm going to start at any numbers, the next highest number below 12, which is 9. Does 9 go into 24? No. Does 4 go into 24? Yes! All right, so 4 is my key. So I'm going to say the square root of 4 times the square root of 6. I'm not writing the square root of 6 times the square root of 4, even though that's okay to do. Are you guys really paying attention?
Yeah. Sorry.
Okay. But I'm not writing the square root of 6 first. I'm writing the square root of 4 first. Because if I wrote the square root of 6 first, this is what will happen. Even though this is okay, it's not okay to me. Because this is what will happen. Then people will say, oh, so the answer is the square root of, they're going to do this, square root of 6, 2.
That looks like the square root.
And I don't know whether that's the square root of 6 times 2 or is the square root of 62. Right? I can't tell. So you always put the number that's a whole number that is not in an absolute value sign in front of it, right? You never put it on the back of it because then it looks like part of the square root thing. Some people are, I'm saying write it this way, not this way.
Yeah.
You always want your perfect square first. Because then when I come down, I'll have just 2 square root of 6. It's already in the right order. Whereas if I do this way, I'll have 6 times 2. Square root of 6 times 2, which sort of looks like the square root of 62. Right? Which it isn't, but that's what it looks like. So this has to be always over here.
Okay.
So if you always write the perfect square first, it will always be there, right? All right, let's try another one. Now we could, let's try another one. This time, let's try 96. Square root of 96. Now we could go half. We could go half and do that method. Let's do this one though. Let's do tree factoring, since we haven't done that one So we're going to do 96. So I know 2 goes into that, right? 2 is that in that 4 times 8, 1 left over, 6, 2 and 6, 8. So 48. All right, 2 times 48. None of those are in this list. Okay, so I got to keep going. All right, so this is, I know 2 goes into that, right? Let's see, 2 goes into that 24 times, right? Am I right?
Yeah.
24. Oh my God! What do you guys see?
24.
A perfect.
What do you see? It's not a perfect square, but it's 2 numbers that are identical.
2s.
2s! So I'm going to do something a little radically different from tree factorization. I'm going to go backwards. Watch this. I am going to do this. I'm going to have those together and it's going to become a 4. And I'm going to put a big box around it. Isn't that cool?
No. Yes.
So suddenly, all I have is 4 and then this stuff. So 24,
and then this stuff.
24, I don't know, I know 2 goes with 24. 24, I think 2 times 12. Oh my God! Oh wait, no, that one's part of this one. See, that's part of that one. So that's not going to help me. So I'm going to have to keep going, because none of those are in this list, right?
2 times 6.
2 times 6, okay, 2 times 6. But 6 is not in this list, but, oh my God, look! There's another couple 2s, so there's another 4.
Wow.
So now my answer is 4 times 4 is 16 times 6. Does that make sense?
So wait, wouldn't that be the square root of 16 times 6?
Right, yeah. So, right, the square root
That's
of
4.
16 times the square root of 6,
So that's 4 times 6.
which is 4 times the square root of 6. Do you see how I'm doing that? You see how I'm using the tree factorization? So it's really useful, yeah.
But don't you keep on doing the tree factor with 6?
Yes, I technically probably should, just to be sure that there's nothing that's a perfect square in there. But there isn't. See? So since there isn't, I'm going to just stick with, because otherwise I would have square root of 2 times 3. I might as well just keep it as 6. If I can't find a perfect square below something, I'll just keep that thing.
Okay.
So does that make sense? So I would actually, just keep it as 6 there in this case. Does that make sense? Does that help a little bit? Because sometimes people were doing it the hard way. They were starting, does 4 go into it? And then they started, does 9 go into it? And then they started, does, you guys listening? Does 16 go into it? And then they said, this is, but yeah, like some numbers will have several of these numbers go into it, right? You want to get the highest number. So this way you shorten your time. You're starting with the highest numbers. Let's do this one this way, the other way, the first way. Half of 96 is?
48.
48. Okay, half of 96 is 48. So I'm going to come over here. 48 is not on here. So I'm going to check, does 36 go into 96? I don't think so. Does 25 go into 96? Definitely not, because it doesn't end in a 5 or a 0, right? Does 16 go into 96? Yeah, and if I don't know, I'd have my calculator. 96 divided by 16, I'll get 6. Right? Then I'll say square root of 16 times the square root of 6. But it saves you time. Does that make sense? Am I losing you guys, or you get it? Okay. And you get this tree factoring. It's really fun when you can use processes like tree factorization that you've learned years and years ago, right? When did you learn that? Like in 4th grade or something?
Yeah, like 4th grade.
Right. So like here, you know it so well, and you can use it to find the factors that you need for this. Okay. I also noticed in Homework Club how few people initially wrote these on their paper, right? How many people wrote these on their paper? Very few people did initially. I really recommend when you're doing lots of radicals, like homework tonight will be lots of radicals, write this up on the corner of your paper so you have it to look at, because that's going to be the first number in your solution, right? Okay. Now we're going to go further. We're okay, right?
Oh, do we get to like add them and stuff now?
Okay. So watch. Now, yes, we're going to start adding stuff. All right. So let me ask you this: what does 4x plus 3x equal?
7x.
What What is it?
7.
Everybody agrees? So you're saying I can keep the x and I just add the coefficients? Is that what you're saying?
Yes.
All right, so 7x. I agree with you. All right, what does 10x plus 4x equal? 14x. Okay, what does 12x minus 6y equal?
You can't really simplify that.
7.
Yes, that's right. It's 12x minus 6y. I can't go any further. These are not like terms.
Wow.
Right?
No.
The coefficients are 12 and 6, but the numbers are, the unknowns are x and y. They're not like terms. I can't go any further. All right. So, similar to my top one, what would this equal? 2 times the square, actually, here, I'm going to do this. I'm going to use the same letters, the same numbers. 4 times the square root of 3
Times the square root
plus 3 times the square root of 3. What does that equal?
7 times the square root of 3. 7 square root of 3.
Does it really? Does it really?
Yes. Yes.
Yeah, think about it. This means I have 4 x's. I have x plus x plus x plus x. This says I have 3 x's. And I'm adding those to x plus x plus x. So I have 7 x's. This says I have 4 square root of 3. Square root of 3 plus square root of 3 plus square root of 3. This says I have 3 more. Square root. Sorry. Where was I? Okay. Square root of 3, square root of 3, and square root of 3. So that gives me 6. No, I just screwed up.
So that gives you 7.
Well, let me start over. I'm a math teacher. I'm really good. I'm not good at using my fingers, right? Okay, so 4 square root of 3's, and then I have 3 more. There we go. We'll add those together. That's 7. Okay, 7 square root of 3's. All right? See, it's pretty easy. So you're just adding the coefficients. All right, what's this one? 20 square root of 5 minus 8 square root of 5.
16 square root of 5. Or no, 12 square root of 5. Yeah, 12 square root of 5.
12 square root of 5, right, exactly. All right. Now, what if okay, what about this? What is
10 square roots of 25 minus 5 square roots of 5.
all right, well, you're getting too hard for me right now. Just hang on one second. How about 6 square root of 2a plus 4 square root of 2a?
10 square roots of 2a.
How many people agree with that?
That sounds right. Yep.
How many people agree? 10 square root of 2a.
Sounds right. Yeah.
You agree? All right, you're right. That's totally right. Because I have 6 square root of 2a, so square root of 2a plus square root of 2a plus square root of 2a. So it doesn't matter what's inside the radical. All it matters is that they are exactly the same if you're going to add the coefficient.
Oh, can you have like
So
crazy
10
big,
square root of 2a.
crazy like problems inside a radical, and the radical will be like, badoo.
Yeah, I'm not quite sure I can picture exactly what you're picturing, but I think so. Yes.
Like if you had like some crazy like squibbly long abstractions,
All right.
and
So
then you had like you have like a really massive radical.
so yeah. So you could do 2 the square root of
8, 9.
b squared plus or b negative b plus or minus the square root of b squared minus 4ac all over 2a plus 3 square root of whatever. Right, same thing. Then you could add the coefficients and you have 5 of those, right? Yeah? Right? So, yes, that's a good question. Yes, you can. So, now, what if I gave you this, though? What if I gave you this?
Oh no.
4 square root of 2 plus 3 square root of 3 plus 2 square root of 2.
Oh, I got it.
6 square root of 2 plus 3 square root of 3.
Yeah.
How many people agree with that?
I agree. Agreed.
What?
Yeah.
Agreed.
Okay, sure.
Agreed.
Yeah. Yeah. So you can, as long as the square root, the number is under the square root sign is exactly the same. I can add this coefficient and this coefficient, so I get 6 square root of 2's plus 3 square root of 3's. Now, the homework Alright, let me just close this, turn this off.